Good morning, children. Welcome back to our maths class. Let us start a new chapter, Numbers and Algebra. First topic, number pyramid. Look at this picture. This is what called number pyramid. And see, children, do you see any relation between the numbers? Pair of adjacent number in the bottom row are added to get the two numbers in the middle row. See, this is the bottom row, middle row and topmost row. When we add these two numbers in the bottom row, we get this number 2 plus 3, 5. When we add these two numbers 3 plus 4, we get this number 7. And when we add the two numbers in the middle row, we get the number in the topmost row. 5 plus 7 is equal to 12. Now, let us take the first number as x. Instead of 2, we write x. So, how we will write 3? We write x plus 1. This is 2. So, here 2 plus 1. And what about this number? It becomes x plus 2. We know to get this number, we need to add these two numbers. X plus x, 2x plus 1. Okay. Then, to get what is here, we need to add these two numbers. X plus x, 2x plus 1 plus 2, 3. So, we get the numbers in the middle row. Now, to get the number in the topmost row, we need to add these two numbers in the middle row. 2x plus 2x, 4x plus 1 plus 3, 4. So, the topmost row is 4x plus 4. And see, children, the number in the topmost row is 4x plus 4. Here 4 is a common factor. So we take 4 outside. Balance what is there? X plus 1. Isn't it? This x plus 1 is the middle term in the bottom row. So we can say that the topmost row is 4 times the middle term of the bottom row. Now look here. The number in the topmost row is 12. And the middle number in the bottom row is 3. We know 12 is 4 times 3, isn't it? So we can say that the number in the topmost row is equal to 4 times the number in the middle of the bottom row. Now, if I am taking this number, middle number as x, okay, middle number 3 as x, what will be here? This is 2, that is 3 minus 1. So here we can write it as x minus 1. And here we can write it as x plus 1. 3 minus 1, 2, then 3 plus 1, 4. Now coming to the number in the middle row, what will come here? X minus 1 plus x plus x, 2x, then minus 1. Here, x plus x, 2x plus 1. To get the number in the topmost row, we need to add these two numbers. 2x plus 2x, 4x, then minus 1 plus 1 will get cancelled. So, in the topmost row, the number is 4x. Here also, see children, the number in the topmost row is 4 times the number in the middle of the bottom row. Now see this pyramid. Here, bottom row is given. We need to find the middle row and topmost row. To get the number here, we need to add this. X plus x, 2x minus y. Here, x plus x, 2x plus y. When we add these two numbers, we get the number on the topmost row. 2x plus 2x, 4x. Okay. Minus y plus y. Get cancelled. So, the number in the topmost row is 4x. See here also, the number in the topmost row is 4 times the number in the middle of the bottom row. Next topic, another pyramid. See, here is a bigger pyramid. Some of the numbers are given. We need to find all the other missing numbers. We know when we add the two adjacent number, we get the number on top of that. 10 plus 1 is 11. Here it is not given, but we know when we add these two number only, we get this number. So to get this number, we need to subtract 1 from 10. 10 minus 1 is 9. See, 1 plus 9 is 10. Okay. Then to get the number here, 9 plus 10 is 19. Okay. Now we can easily find these numbers. 11 plus 10, 21. Then 10 plus 19, 29. Then 21 plus 29, 50. This is how you have to fill the pyramid. See the next pyramid. Now let's fill this pyramid. Here 10 plus 2, 12. So here it is 12. We don't know this number. So to get this number, we will subtract this number from 10. Okay. 10 minus 2, 8. 2 plus 8 is 10. Then 8 plus 10, 18. Here 12 plus 10, 22. Then here 10 plus 18, 28. And on topmost row 22 plus 28 is 50. Okay. In this type of pyramid, when there is 4 steps, the number in the topmost row is 5 times the common number. Here the common number is 10. Okay. So when there is 4 steps, the number on the topmost row is 5 times the common number. Pyramid, the bottom row is given. We need to fill the missing boxes. Here 10 plus x. So we write 10 plus x. To get the number here, we need to add these two numbers. 10 plus 10, 20 minus x. What is the number here? To get the number here, we need to add this. 10 plus 10, 20 plus x. And the number here is 10 plus 20, 30 minus x. Now coming to the topmost row. 20 plus 30, 50 plus x minus x get cancelled. See here also the number on the topmost row is 50. It is 5 times the common number 10. 5 into 10 is 50. Now see this pyramid, children. Here only the common number is given. Okay. We need to find all the other missing boxes. In this case, you can take any number which is less than 9 as the second number. So here I am going to take it as 2. Okay. Now we can fill. 9 plus 2, 11. And here 9 minus 2. Okay. That is 7. Here 7 plus 9. That is 16. And again here 11 plus 9. That is 20. Here 9 plus 16. It's 25. And on the topmost row 20 plus 25. That is 45. And here also you can notice that the number on the topmost row is 5 times the common number 9. 5 into 9 is 45. See here the common number is x. I am taking the second number as y. So what will be this number? X plus y. And what about this? From this we need to subtract this. X minus y. And the number here is x plus x, 2x minus y. Here x plus y plus x. X plus x is 2x plus y. And the number here is x plus 2x is 3x minus y. Then comes the topmost row. 2x plus 3x is 5x. Plus y minus y get cancelled. So the number on the topmost row is 5x. Here also this number is 5 times the common number x. See the next pyramid, children. Here the bottom row is given 1, 2, 3, 4. We can fill the other number. 1 plus 2, 3. 2 plus 3, 5. 3 plus 4, 7. Then here 3 plus 5, 8. 5 plus 7, 12, and topmost row 8 plus 12, 20. See, in this case, here there is no common number. So in this case, the number on the topmost row is 4 times the sum of the middle term of the bottom row. That is here 2 plus 3. 2 plus 3 is equal to 5. What is the 4 times of 5? 4 into 5 is 20. So we can say that topmost row is 4 times the sum of the middle terms of the bottom row. Next topic, playing with 11. Look at this pattern. 12, 23, 34, 45, etc. The number starts with 12, then add 11, add again, and so on. This 12 we can write it as 11 plus 1. 11 plus 1 is 12. And 23 we can write it as 22 plus 1. 34 we can write it as 33 plus 1. 45 we can write it as 44 plus 1, etc. Now this 11 plus 1 we can write it as 11 into 1 plus 1. 11 into 1 is 11. Then plus 1. And this 22 plus 1 we can write it as 11 into 2 plus 1. 11 into 2 is 22 plus 1. This 33 plus 1 we can write it as 11 into 3 plus 1. 44 plus 1 we can write it as 11 into 4 plus 1, etc. And this we can represent in algebraic form as 11n plus 1. 11 into n. N can be any number plus 1. Now see the next pattern. 21, 32, 43, 54, etc. This 21 we can write it as 11 plus 10. 11 plus 10 is 21. 32 we can write it as 22 plus 10. 43 we can write it as 33 plus 10. And 54 we can write it as 44 plus 10, etc. Now this 11 plus 10 we can write it as 11 into 1 plus 10. 11 into 1 is 11 plus 10. 22 plus 10 we can write it as 11 into 2 plus 10. And 33 plus 10 we can write it as 11 into 3 plus 10. 44 plus 10 we can write it as 11 into 4 plus 10. Algebraic form of this is 11n plus 10. Okay, 11 into n. N can be any number plus 10. Now, if we add both the patterns, okay, if we add the top and bottom number in order, we get like 12 plus 21, 33, 23 plus 32, 55, 34 plus 43, 77, 45 plus 54, 99. All these are multiples of 11. Now we will add the algebraic expression of these two patterns. That is 11n plus 1 plus 11n plus 10. When we add 11n plus 11n, it is 22n plus 1 plus 10, 11. Here 11 is a common factor. So we take 11 outside. 11 into, what is balance there? 2n plus 1. So the algebraic form of the sum of these two patterns is 1 into 2n plus 1. Now let us substitute the different values for n and see whether we are getting this number pattern. If n is equal to 1, when we substitute n in this algebraic expression, we get like 11 into 2 into 1 plus 1. Okay, 2 into n. So instead of n we can write 1. 2 into 1 plus 1. That is 11 into 2 into 1, 2 plus 1. Thus we can write it as 11 into 2 plus 1, 3. 11 into 3, 33. Now if n is equal to 2, when we substitute 2 instead of n, we get like 11 into 2 into 2. Instead of n we write 2 plus 1. That is 11 into 2 into 2, 4 plus 1. That is 11 into 4 plus 1, 5. 11 into 5 is 55. Now, if n is equal to 3, when we substitute, we get 11 into 2 into 3 plus 1. 2 into n. Instead of n, we write 3. That is 11 into 2 3s are 6 plus 1. That is 11 into 6 plus 1, 7. That is equal to 77. 33, 55, 77 are the sum of the two number patterns. Okay. So we can say that the general forms such as 11n plus 1, 11n plus 10, 2n plus 1, which indicates an operation, are called algebraic expression. Question. Find the algebraic expression for the numbers got by adding 10 repeatedly to 1. That means 1 plus 10 equal to 11. We add 10 to 1. So we get 11. Next number is, to this 11 we need to add 10. 11 plus 10 is equal to 21. Next number, to this 21 we add 10. 21 plus 10, that is equal to 31. Next number, 31 plus 10, that is equal to 41. Then etc. So we get the numbers as 11, 21, 31, 41, etc. This 11 we can write it as 10 plus 1. 21 we can write it as 20 plus 1. 31 we can write it as 30 plus 1. 41 we can write it as 40 plus 1. Now again we can write this as 10 into 1 plus 1. 10 into 1 is 10 plus 1. Then 20 plus 1 we can write it as 10 into 2 plus 1. 10 into 2 is 20 plus 1. Then 30 plus 1 we can write it as 10 into 3 plus 1. 40 plus 1 we can write it as 10 into 4 plus 1. Now coming to the pattern. So algebraic expression we can write it as 10n plus 1. N. This n we can write it as any number. So we can write algebraic expression as 10n plus 1. Next topic, two-digit number. N is equal to 1, 2, 3, 4, etc. 9. Here, to form two-digit number, we can only substitute the natural number from 1 to 9 instead of n. Let's see how. Let us take an example as 10n. In this 10n, when we substitute the value of n as 1, 2, 3, etc., let's see how it comes. When n is equal to 1, it comes like 10 into 1. 10n. Instead of n, we substitute as 1. So 10 into 1 is 10. When n is equal to 2, it comes like 10 into 2, that is equal to 20. When n is equal to 3, it comes like 10 into 3, that is equal to 30. And it will goes on like that. When n is equal to 9, it comes like 10 into 9, that is equal to 90. So here we get the pattern like 10, 20, 30, 40, etc. 90. Now let's take another pattern 10n plus 1. Here when n is equal to 1, we get like 10 into 1 plus 1. 10n. Instead of n, we substitute the value of n as 1. 10 into 1 plus 1. That is equal to 10 into 1, 10 plus 1. That is equal to 11. When n is equal to 2, it comes like 10 into 2 plus 1. That is equal to 20 plus 1. That is equal to 21. When n is equal to 3, it comes like 10 into 3 plus 1. That is equal to 30 plus 1. That is equal to 31. And it will goes on like that. And when n is equal to 9, it comes like 10 into 9 plus 1. That is equal to 90 plus 1. That is equal to 91. So here the patterns come like 11, 21, 31, etc. 91. Now let's take another algebraic expression 10n plus 2. When n is equal to 1, it comes like 10 into 1 plus 2. That is equal to 10 into 1, 10 plus 2. That is equal to 12. When n is equal to 2, it comes like 10 into 2 plus 2. That is equal to 20 plus 2. That is equal to 20 plus 2, 22. When n is equal to 3, it comes like 10 into 3 plus 2. 10 into 3 is 30 plus 2. That is equal to 32. It will goes on like that. When n is equal to 9, it comes like 10 into 9 plus 2. That is equal to 90 plus 2. That is equal to 92. Here the pattern comes like 12, 22, 32, etc. 92. So in short we can say that all the two-digit numbers come in the form of 10n plus m. Question. If we subtract from any two-digit number the sum of its digits, we get a multiple of 9. Explain why this is so using algebra. Two-digit number is equal to, we already see what is the form of two-digit number. 10n plus m. Okay, m is the number in the ones place and n is the number in the tens place. That's why we multiply it with 10. Okay, and the question is, from this number, if we subtract the sum of these n plus 1, the answer is multiple of 9. We have to express it in algebra. So we write sum of the digits is equal to n plus m. Okay, when we add the digits in the ones place and tens place, it comes like n plus m. The number on subtracting comes like, we need to subtract this from this. So we write 10n plus m minus n plus m. When we open the bracket, it comes like 10n plus m minus n, minus into plus, minus m. 10n minus n is equal to 9n. Plus m and minus m get cancelled. See here, the answer is multiple of 9.